Let's have a look at this variation point with its default implementation here in that base class. Suppose you want to make that base class more abstract and so more stable. So you decide to move the default implementation down the inheritance hierarchy into the derived classes which use it. So you just take the code and cut and paste it into the derived classes, right? Well, there's a better way to do this. This is a simplified example which just has that base class and a few derived classes. Some use the default implementation provided by the base class, some are extending it, and some are overriding it completely. Let's imagine this code base would be a little bit bigger than just those 6 projects. Maybe a few hundreds of thousands of lines of code. And let's assume this base class has 10, 15, or even 20 derived classes. How do we ensure that we don't miss any derived class during this refactoring? Of course, we could now just use the capabilities of our IDE to do the analysis, note down the results, and start adapting the code accordingly. Well, again, I think there is a better way, and here it is. First, we make the variation point abstract and convert the default implementation into another protected method. If we now check the derived classes for compiler errors, we will see that the compiler, of course, forces us to implement the abstract method now. And we do this by just calling the default implementation we still made available through the base class. Let's check the other classes and do the same here. And of course, the compiler will also complain if we still try to call the abstract method. So we have to change also those derived classes which just extend the default implementation from the base class. So instead, we call the default implementation method we provided. If we now compile the project, we see that it is compiling successfully. And so we know that all the derived classes are implementing the abstract variation point. We could now run all our unit tests also, but actually the compiler here is our most important quality gate. And now we would submit these changes as a first step of our refactoring to our version control system. In the second step, we will simply remove the abstract variation point from the base class. And of course, the compiler will now complain again, simply because there is now nothing to overwrite in the derived classes. So let's fix that first. We will simply make this private, and we will do this on all the derived classes. Of course, we now also have to move the code which was calling the variation point into the derived classes. So let's do this as well. Looking again at our base class, we see that the default implementation is now free and we can decide what to do about it. We could now just either copy it into the derived classes which really use it, or we can maybe factor it out into some class which can then be used by those derived classes which need it through aggregation rather than inheritance. In this case, we decide to just move it into the derived classes. And we simply remove the default implementation method from the base class, obviously. So let's check the derived classes. We need it here and here and one more time. And we're also done with the second step of the refactoring. Let's compile the project again. Succeeded. Of course, we could now run our tests again, but we can already be very confident that the refactoring was successful. Finally, we would also submit these changes as a second step of our refactoring to our version control system. And we are done. By making this refactoring a simple two-step approach with compile-breaking changes, we can use the compiler to prove that the refactoring is indeed behavioral non-breaking and all derived classes got properly adapted. Furthermore, by submitting those two steps separately to our version control system, we extend the idea of clean code in time. We do not only produce source code which is easily to understand by humans, we also create a version control system history which is easy to understand by humans, as it reads like a step-by-step refactoring log. And if you are now interested in how to apply a similar technique to introduce some requirement change into a bigger code base, then watch this video next.